Hi there, welcome back to MA 211. You should be continuing to read or reread section 3.3 for more information on solving these higher order constant coefficient ODEs. So let's just go ahead and continue, and we'll see we're in a section on repeated roots. So these equations will have repeated roots to their characteristic equation. So if I take a look at this first ODE, its characteristic equation will be r squared minus 4r plus 4 equals 0. We'll go ahead, we can factor that as r minus 2 times r minus 2. And we see that we have a root at r equals 2, and it's repeated twice. And so our solution will be y of t equals, well, we'll get the first normal solution, c1 e to the 2t. And now our second solution with a repeated root will be c2t e to the 2t. And that's it. Alright, so let's go on and we'll try another problem. Here we've got a third order differential equation. We'll write down the characteristic equation again. It's r cubed minus 5r squared plus 8r minus 4. If we just go ahead and guess, we can see that 2 is a root to this equation. And if we do polynomial division, we can see that that left-hand side is really r minus 2 times r squared minus 3r plus 2. That's 0, and then I can further factor the left-hand side. That's r minus 2 times r minus 2 times r minus 1. And now we can see the three roots. They are r equals 1, and you have r equals 2, and that's repeated twice. And so your general solution is going to be y of t equals, you'll have one part corresponding to the r equals 1, so that's e to the t, plus you'll have two parts corresponding to the r equals 2, so that'll be c2 e to the 2t, and then a second part c3t e to the 2t. Okay, now for solving these guys, again, I just went ahead and guessed that r equals 2 was a root of the ODE, or a root of the characteristic equation. If you want to use maple or something like that, I'm fine with it on homework. I am just expecting that if I give you something like this cubic that has a root that's easy to guess, that you can go ahead and find all the roots to the equation. Okay, let's go ahead and do just one more example. Again, we'll write down the characteristic equation, r squared minus 2r plus 1 equals 0. We can factor that as r minus 1 times r minus 1 equals 0. We have a root at 1. That's repeated twice. And so our general solution will have two parts, c1 e to the t and c2 t e to the t. And that's it.